Today we're working on section 4.2, graphing polynomial functions. I am going to only graph one of these in this video, but if you're in my class, you'll find more examples and definitions in the notes. And make sure to look on the homework page because it has written instructions on the steps we take to graph a polynomial function. So I've written down the first one for us. H of x equals x cubed plus 3x squared minus x minus 3. The first thing that you want to do is find the end behavior like we did in the last section. Okay, well, to find the end behavior, we need to look at the degree and the leading coefficient. Remember, I like to write LC for leading coefficient, just so I don't have to write it out. The degree, remember, is your highest exponent, so my degree is 3. And my leading coefficient is connected to that term with the highest exponent, so it's 1. So my degree is odd. My leading coefficient is positive. Remember, the degree being odd means that the end behavior is going to be opposite on both sides. So one's going to go up, one's going to go down. And the leading coefficient tells you the right side. So the right side's going up. And the other side, the left side, must be going down since they're opposite. And really, just doing that at the beginning is a check for yourself at the end. When you get it totally graphed, you want to make sure it matches the end behavior you had at the beginning of your problem. The second step is finding the x-intercepts. Okay, well, remember to find the x-intercepts, you plug 0 in for y and you solve for x. If you have an equation with 4 terms and you're trying to solve for your x, you might be able to factor by grouping. Okay, so this is a prime candidate for factor by grouping. Before I group them, if there's a minus sign in the middle, I'm going to put plus the negative because that negative only goes with that term right there. And then I'm going to group them. And you ask yourself, what can come out of both of these two terms? What can factor out? Well, an x squared. And we'll have left x plus 3. Well, what can factor out of both of these two terms? Not much. But notice that they're both negative. When they're both negative, at least factor out a -1. That's probably going to be helpful. So that just changes our signs here. And what you want to happen is both of these factors to be the same, which they are. If they're not, look back at the problem, see if there was something more that you could take out. And worst case scenario, maybe it's not a good factor by grouping problem. But this one worked. So I'm now going to factor out the x plus 3. So we have x plus 3. And we have left over x squared minus 1. Well, I can factor that one again. It's a difference of 2 squares. And now I have it factored out completely. So I'll set each factor equal to 0 and solve. So I came out with my x-intercepts -3, 1, and -1. Before I do the next part, I find it very helpful to make a number line and just put the x-intercepts on here in order, of course, from smallest to greatest, because that shows us the intervals that we're about to test. Okay, so the easiest thing to graph the polynomial function completely is to test your intervals. So I make myself a table, and in this table I have a row called interval, test value, function value, sign of h of x, or of course whatever the name of your function is in your problem. Ours was h of x, and location of points. Okay, and this is why I drew this number line right here, because that's going to fill out the top row. It's our intervals. My first interval is -∞ to -3. My second interval is -3 to -1. Then I've got -1 to 1. And finally 1 to infinity. Okay, so once you find your x-intercepts, put them on a number line so that it'll easily make your intervals easy to find. Okay, the test value, well, it's just what it says right here. You're going to test something inside that interval. Now make sure it's inside the interval. If you pick the end point, well, that's going to give you 0 because it was an x-intercept. So you have to pick a number inside the interval, but you can pick any number you want. I picked -4. I always like to pick exactly in between these two numbers. You'll see why when we graph it. So I picked -2, 0, and 2. Okay, so just pick a number inside each of the intervals. The function value, well, that just means you're going to take your test value and plug it back in to your original problem. So let me just do that here with the first one. So we've got -4 cubed plus 3 times -4 squared minus -4 minus 3. Okay, so that'll give us, let me make sure I've got that right. -64 plus, all right, that'll give us a positive 16, and then times 3, so 48. And then, of course, a negative times a negative is a positive. So let me just add those up. -15. Okay. And then you do that with all of the other test values that you picked. Remember, you're just plugging them in to your original problem. So I already did this before I started the video. So let me just write down what I got. Okay, and then the rest of the table's fairly simple. All you have to do is the sine of h of x. Well, that's the sign that you got when you plugged it into the function. So this one was negative, this one was positive, this one was negative, this one was positive. Okay, and location of points, it's just wanting you to say, is it below the x-axis or above the x-axis? Well, of course, if it was negative, it was below the x-axis. If it was positive, it was above the x-axis. And that's just going to help us when we graph it. When we're looking at our table, we can see when we're plotting the point, is it supposed to be above or below the x-axis? It just is another way to check your answer when you're completely done. And step 4, this was step 3. Step 4, find the y-intercept. Okay, well, to find the y-intercept, we plug 0 in for x and solve for y. And we see that we're just going to be left with -3. Okay, so 0, -3 is our y-intercept. Notice that we actually already have that point in our table up here as well. Okay, so this table is really helpful because it gives you the main points that will help shape your graph. This is your x value, and this is your y value. So we've got the point -4, -15, -2, 3, 0, -3, and 2, 15. I'm just going to move this over a little bit so we can still see it, but I'm ready to graph. And I made it extra long because I see that I've got 15 on here and could have extended it down too. I'm going to go ahead and just draw the dashes. And my x values, it doesn't look like we have too high of values for those. So again, pick wisely, because you can pick any test value you want, but -infinity to -3, I'm sure glad I didn't pick -1000 because I'd have to put that on my graph. Okay, of course, feel free to go up by 2s or 5s if it makes it a little easier. I just think it's easy to plot the point if I have them going up by 1s. So my first points, well, let me go ahead and just graph my x-intercepts first because that's going to be easiest. So remember, my x-intercepts were -3, 0, -1, 0, and 1, 0. Okay, and then the other points that are going to help us shape our graph are these points we found on the table. So -4, -15. -2, 3. 0, -3, and 2, 15. Okay, so I'm just going to carefully draw my line. Okay, so it started off right here. I'm going to try not to miss any of my points. A polynomial function has nice smooth curves. Okay, and you can see why I picked the number exactly in between in this interval, because it's going to end up in the middle, so you'll know exactly how far up and where it's going to curve around. Okay, so that's the reason why I take the time to figure out what's the number exactly in the middle. Really, you can pick any number and you're just sketching your graph so that you have a rough idea of what it looks like. Okay, there are some things that you can check at the end when you're done. Okay, of course, first of all, check your end behavior. You said it was going to go down on the left, up on the right. Well, good. We've got down on the left, up on the right. I also talk about x-intercepts, your degree, and your turning points at the beginning of the section. Okay, you can see the degree in your problem was 3. Well, that means at most there will be 3 x-intercepts, and at most just subtract 1 from it, so there will be at most 2 turning points. Well, yeah, when we found our x-intercepts, we got 3 of them. You might not get 3, you might get less than that, but at most you're going to have whatever your degree is. Okay, and then you're going to have at most subtract 1 from it, so 2 turning points. Okay, so when we look at our graph, we had our 3 x-intercepts, and here is where our graph changes direction. It only does that 2 different places, so we had 2 different turning points. Okay, so those are just a couple things you can check out when you're done to make sure that you did your graph correctly. Okay, and that's all for today.